So welcome all to our second segment of today, Explainability and Trust, the importance of the human factor. This second segment will be moderated by Ms. Giulia del Gamba. And I'll now speak a few words about her. She works on the Benk Intesa Sanpaolo, where she deals with policies about emerging technologies within the Chief Data, AI, Innovation and Technology Officer area. Furthermore, she also sits on the founding editorial board of Springer's AI and Ethics Journal. Prior to this, Giulia started her career in Intesa Sanpaolo in 2016 as AI ethicist, focusing on data protection and algorithmic trustworthiness. She has produced several works on the topic of responsible AI and on methods for artificial intelligence, fairness, and transparency. So I would like you to give your warm welcomes to Ms. Giulia.
Thank you, Vitor. Hi, everyone, and thank you so much for being here. Welcome to panel 2 of IPEN 2023. So here with us today, we have a great lineup of panelists. I will briefly introduce them, and then we can jump right in. Our first speaker is Dr. Zachary Lipton, Assistant Professor of Machine Learning and Operations Research at Carnegie Mellon University. His research includes the theoretical and engineering foundations of robust and adaptive machine learning algorithms, applications to both prediction and decision-making problems in clinical medicine, natural language processing, and the impact of machine learning systems on society. Welcome, Zachary. We are very delighted to have you here. Without any further delay, you can start with your presentation.
Thanks so much for having me, and sorry that I can't be there in person. So I'd like to begin by providing some background and introducing a critical perspective on what I think is a kind of confusing and paradoxical nature of the modern field of explainable AI. To start off with, I want to avoid some amount of confusion. So this critique is going to be focused specifically, and when I say XAI, not on the kind of like hopelessly broad set of practices that encompasses, but precisely around these so-called explain the black box methods, and what I believe is a set of perhaps premature or possibly misleading ways that they're being applied. Often in maybe critical industries like healthcare, where you think maybe the bar should be higher and folks should know better. And I kind of want to differentiate this set of explain the black box methods from some of the other sort of more straightforward notions of transparency that have been discussed, or around I think what Brent called transparency, or one of the other speakers referred to as like process transparency, which I think is a kind of different category of items, and that's really not the target of this critique. So on one hand, explainable AI, or this explain the black box variety of XAI, is on the rise. The phrase is inescapable. It's a preferred term of art for a broad coalition of policymakers, private stakeholders, and researchers, all concerned with the responsible deployment of machine learning. And yet at the same time, for all of the like snowballing currency that this term is gathering, the academic discipline associated with actually explaining the black box, the actual technical progress has been sort of meandering, generally sort of mired in confusion over what precisely are its objects of inquiry, what are its aims, and how do its methods in any way relate to its aims? This is sort of the focus of a critique that I think kind of led to my kind of being inextricably involved in this field in 2016 in a paper called The Mythos of Model Interpretability. And I think this kind of confusion over what problems are being addressed and what, if anything, the proposed methods have to do with those problems persists to this very day. Viewed in terms of prominence in the public discourse or the volume of academic activity in terms of, say, the number of papers, you might think that explainable AI is in a kind of golden era, enjoying sort of ever-growing attention, private sector funding for entrepreneurs, adoption of products and methods in corporate environments, and plenty of corporate employment for practitioners. And on the other hand, if we view this field in purely scholarly terms or as a technological discipline, it's sort of stalled as a discipline. We have reams of papers, but most of them have not actually proven useful in any kind of concrete empirical sense for addressing the myriad problems that ostensibly motivate the field. So, the central kind of conundrum here is how we wind up in the situation of sort of burgeoning demand and a seeming like growing of buzz, coupled with this lackluster progress. I think this is a paradox worth unpacking. So to start, I welcome any critical questions. I know this is a somewhat provocative account. I want to start with like a bird's eye view of the field of AI, the origins, or I think what I would attribute to some of the motivations for some of these calls for explainability, the emergence of XAI as a technical discipline that ostensibly addresses these concerns, and sort of why I think it sort of fails to connect on its aims. And then I'll try to meditate a little bit at the end on what I think is a strange combination of the economic, social, and political forces that have led us to sort of be in this strange situation of endorsing a research narrative that isn't actually bearing fruit. Um, I also want to at some point to situate this narrower discussion of the sort of explain the black box notion of the technical XAI field within a broader conversation about transparency and accountability, where I think there has been some genuine progress towards developing some useful practices and norms around transparency and disclosure. So to begin, it's like, what is AI that it warrants explaining? And I could paint a sort of caricature of the field of AI. We're using the term AI now. It's sort of a weird historical misnomer in that, if anything, what we're talking about is the field of machine learning that sort of supplanted AI, and we've sort of gone back to using the term AI, not because anything changed technically, but because we just people wanted a word to convey how excited they are about where progress seems to be going, or a sense of development in the field. If the nomenclature doesn't change, how can we know we're truly progressing? And so as an academic discipline, machine learning can actually seem hopelessly broad. And I'll contrast this with the narrowness of maybe some of the practice of machine learning that we're concerned with. So as an academic field, machine learning claims nearly every area of human endeavor as an application domain, and happily claims nearly any technical methodology that's used by anyone who works with data as among its methods. At a machine learning conference, you'll find people applying nearly any statistical method, no matter how traditional or cutting edge, and calling it all machine learning, for purposes of predicting nearly any target in nearly any domain of interest. You'll find neural network researchers searching for the next architecture or training strategy. You'll find Bayesian statisticians and alpha frequentists. You'll find information theorists, roboticists. You'll even find people who work on the sort of science of decision making. You'll find people who are card-carrying researchers in reinforcement learning and the theory of reinforcement learning, and in the discipline of causal inference from observational data or experimental data. These are all parts of the academic field, so it's hard to make a broad statement about the academic field or what its commitments are. Sort of few fields have fewer commitments. It's both a strength and the weakness of the field, perhaps, but I think it's part of why the field is so vibrant is that it has such low borders, and has so few commitments about who can claim to be part of the discipline. So there is this like diversity of thought, diversity of methods. There is a lot of machine learning activity that ostensibly addresses or attempts to address the foundations of decision making, of robustness, et cetera. But against this sort of like broader academic community, there is the actual practice of machine learning. what's actually taking place 95% of the time in industrial applications. And this tends to follow an actual, a pretty narrow pattern. I think the majority of applications, which is we take some complicated real world problem of interest, maybe some kind of decision making where we're hoping to deploy some kind of automation. This problem often has a lot of moving parts, a lot of desiderata. The purpose is to make decisions. The purpose is to have some sort of impact. But we sort of throw all of that away. And what we do is we cast for something that seems like a plausible surrogate prediction problem. What is a prediction problem where if you could do that prediction problem well, you could imagine conceivably turning your predictor into some sort of heuristic for making that decision. So instead of thinking about how do we make good hiring decisions such that our teams are more effective or productive, we think of something like, let's predict what the outcome of a previous hiring committee would be, or let's predict based on the data available to us whether this person, if hired, would be promoted or would be retained based on historical data. Or rather than predict what would be an engaging set of curations, we think what is most likely to be clicked on. So we substitute a complex real-world problem for a surrogate prediction problem. We identify some historical data of convenience. We designate some of these variables as features, a particular one as a target. This data, it's often what data we had access to, perhaps a feature of the machine learning community compared to, say, a statistics community or natural science community or social science community, as it tends to, this is a sweeping generalization, but we tend to be maybe on the whole less critical about where our data came from and whether it's fit to task, and think more in terms of getting data of convenience and training a predictive model and just seeing how well it does. So we train a model, and then once we have a model, if we think we have some signal there, we then try to come up with some sort of heuristic. We either use this model as sort of an input to a human, we provide it and we call it analytics, and we say this is a score to guide a human decision maker, or we come up with some way of automating a decision based on the outputs of the model. If the score is above some threshold, we'll submit the resume through to the hiring committee. Otherwise, we'll screen it out, something like that. And so at the end of the day, a company then automates the decision in practice by feeding through data representing some new case of interest. As we formulate that as a representation, feed that as the current context to the model, get the output of the model, and then act according to that output. And so faced with a situation in which potentially important or consequential decisions are driven by such systems, some stakeholders are rightly concerned, and they ask questions like, why did the software make a particular decision? Do the predictions rely on causal features? Did they merely pick up on spurious correlations? Are the decisions potentially of a discriminatory nature? Will the model work reliably in new environments? And somehow all of these different kinds of questions often get collapsed onto something like, you give me an explanation for why the model is doing what it's doing. I think underneath that question is actually this, it's not a search for a single thing called an explanation. I believe that question is actually concealing a set of concerns about not looking after one particular thing, but sort of inquiring after the vast set of things that should be accounted for but weren't. I'd like to note here that the illusion between the real problem of interest and the prediction problem of convenience is kind of the original sin here. It's in that recasting that we often forget about the fundamental nature of decisions. For example, with hiring decisions, the fundamental purpose of a policy is to set a coherent set of incentives. You set a set of incentives and you expect people to go out and try to improve their resume to be in better standing with respect to the incentives that you're putting in place. But once we put on prediction goggles, we forget what a policy is. We forget what a mechanism is, and we start thinking about things like, if we disclose the model, then people might try to game it. People might try to manipulate it. We forget that the whole purpose of a coherent policy is actually to invite this kind of manipulation. It's to encourage people to try to go out and comply with a set of incentives that we're putting out there in the world. Unfortunately, this kind of conceptual clarity is often lost, both on stakeholders who kind of don't unpack the problem, but just sort of like ask for explanations and don't really understand necessarily the full breadth of what's missing from the technology that's being used. And also on researchers in the XAI space who I think are often eager to offer a technical solution, but don't necessarily understand the questions that motivate the call for explanations. I think it's sort of an attitude of, oh, you want an explanation? I'll give you an explanation.
Zachary, I'm
What should
sorry
we
for
call an
interrupting.
explanation?
I would ask you to wrap up whenever you can, please. I'm sorry for this.
Sure. I've just got a couple minutes. So overall, this XAI field has emerged, focusing not on this full breadth of problems that I think are underlying these calls for explanation, but really kind of looking more myopically on these questions around explaining model internals or model behaviors. And the problem is that, unfortunately, we lack a precise formulation of what it means to explain a model internal or a model behavior. The question of why did a model make a particular prediction on a particular output doesn't quite have a clear technical specification. Why with respect to what universe of causes? So what we've wound up with is a sort of litany of kind of heuristics for making attributions. We have methods like LIME, SHAP, GradCam, integrated gradients, counterfactual explanations, although they're slightly different in their nature. But each method has some notion of a counterfactual baked in, but there's no coherent principle for how one should sort of choose the relevant counterfactuals. Overall, I think the very strange thing here, and I'll kind of leave this for further discussion, is that I think we're in this strange situation where we have this very deep set of real world concerns. They've been collapsed onto a call for explanations, and we have a set of methods that don't really address any of those underlying desiderata, and yet they're being adopted. And I think that it's really kind of behooves us to sort of interrogate this process and figure out why is it that we have a set of methods that we know all disagree with each other. We're not quite sure what, if anything, is the right technical question they're supposed to be addressing. We've subjected them to multiple sort of human studies of efficacy, almost all of which these methods have failed, and nevertheless, they're being adopted and sometimes mandated. And so overall, I don't believe that the technical products being produced in the current XAI literature are at the level of maturity that they can participate meaningfully in discussions of responsible application of AI or of its regulation. They might be interesting features, but in a if people find them useful kind of mandate, not in a they satisfy some sort of regulatory hurdle mandate. I don't think this critique applies to the much broader set of concerns or set of work that's been done around transparency of process of communicating the exact form of a model or how it was trained or how various decisions were made. I think these are all important steps of progress towards giving users some amount of agency. But I do worry that we are adopting a set of technologies and sometimes even mandating them, not because they actually solve the problems that we're facing, but because they claim to, and they give us a kind of cover. They give policymakers cover, they give researchers jobs, they give corporations the appearance of being proactive or perhaps even of complying. But I worry that we risk sort of participating in a kind of smokescreen that is obscuring problems rather than solving them.
Thank you so much, Zachary. A lot of interesting points have already been raised. So our second speaker is here, Michaela Bank. Ms. Benk is a PhD candidate at the Mobiliar Lab for Analytics at ETH Zurich, specialized in the area of trust in human-AI interactions. Her research aims at developing a rigorous understanding of the underlying mechanisms of trust in AI, as well as identify practical implications that can inform the design of explainable AI methods. Welcome, Michaela, and thank you so much for being here.
All right, so my goal for today is to convince you that we cannot have effective explainable AI without a human-centered approach. And so you will, okay. Sorry, this is because I wanted to be fancy and have animations, so we now have to have of this. But so yeah, I would like to start with a small story. When I first started my PhD in 2019, the idea of human-centered explainable AI was still in its infancy, and I remember one of the first things I read was a paper that was mentioned actually in the keynote, a paper by Tim Miller, who repurposed a very striking title. So the inmates are running the asylum. And what he meant by that is that explanation methods at the time were mainly made by computer scientists for themselves, and therefore based on their intuitions of what makes sense and not on solid foundations of how humans really explain things to each other. So this work started to sort of push toward more collaboration between the sciences and to build methods that integrate what we know from the social sciences about how people explain things to each other into how we build these methods. And quite a lot of progress has happened in the last years. And unfortunately, I only have 10 minutes, so I cannot share with you everything we have learned since 2019. But I will try to give you a little glimpse into some of the human elements that are relevant for human-centered explainable AI. And some of them, actually, two main elements were already touched on in the keynote, so I will go a bit deeper into that. So I will start with a very trivial example, even more trivial than the glass breaking. So imagine a person is sitting on the couch and you're asking the person, why are you sitting on the couch? Now, one possible answer, one possible explanation is because it's comfortable. And this is, in a sense, a valid explanation because it's probably true. Couches tend to be comfortable, and that's why we sit on them. However, how meaningful that answer is depends a bit on the context and who is asking this question and why. And generally, when we ask questions, and especially in the context of AI, we usually ask a question with respect to some anomaly, something that's unusual, some event that requires clarification. And a couch being comfortable is not really all that surprising, at least to an adult. Perhaps if a child was asking that question, then this answer might be fitting. Now, a second option is because I did not know what time it was. And the implication here is quite different, right? So you're probably asking why is this person sitting on the couch because something else was supposed to happen. The person was supposed to get ready, walk out the door. And you both have a shared understanding that that was the case. And also in terms of both of those answers, even if it's a child or an adult, that's part of a conversation, right? Probably there might be follow-up questions. So what's important here to realize is that the term explanation is actually ambiguous. So it can refer to, on the one hand, the process of explaining, which is really a transfer of meaning between two individuals, or the product, which is the actual thing that does the explaining, and which is what we usually refer to. And why is this important? It's because if we think of explanation simply as a product, without really taking into account the person that's asking the question and the context, then we might end up with an explanation that's not very meaningful. So my focus today is on the process, and I will share with you just a few theoretical elements before moving a bit into the practical implications. So to start with, let's take again the scenario where the person is sitting on the couch. It's called the explanandum, the thing that we want to explain. And now, when we ask a question about some event that is strange to us, we usually have some alternatives in mind of what could have happened instead. These alternatives are called counterfactuals. So in our example, for example, in the event that the person is sitting on the couch, what are some of the other alternatives to sitting on the couch? It could be, for example, sitting on the floor. And so someone might say, because it's comfortable, fitting to that scenario, that alternative, the person is could be sitting on the floor instead, but they're not sitting on the floor because it's less comfortable than the couch. Another option is that the person could be walking out the door. And so here, because I did not know what time it was, makes more sense, right? And the implication is that if I had known what time it was, I would have walked out the door. There's a lot of other alternatives as well, standing, jumping on the couch, sitting at the table. And so what's important here to realize is that an explanation takes place relative to a background space of alternatives, and there is the need to have a shared understanding of what the space of alternatives is for an explanation to be effective. So this is why counterfactual explanations, which we've already heard of, is a popular explanation method, because they're considered human-friendly, they're contrastive. They tell us what changes would need to occur for an alternative outcome. What we can also see here is that there is no one explanation that fits all the possible alternatives. We need to take into account the person that's asking the question. And for us humans, especially this example, is very trivial, but for an explainable AI system, it's not so trivial. We might have a quite large space of alternatives, and we must be very explicit about what we choose. So another thing that we know is that people are selective in what they choose to include in their explanation. So if you think of all the events that led up to an event, which is also called a causal chain, the chain can get quite long, probably too long for most people. So what we want to do is fill the necessary gaps. And so, for example, it might be useful to tell someone, you were not aware of the time, and the battery of the watch, for example, stopped working. But unless you're someone who's really interested in how watches function, you don't need to go all the way back to all of the reasons why the watch was broken. So we select explanations that suit our purpose, and then the ones we select depend on the context and the person asking the question. And again, this might be trivial for us, but if we build explainable systems that answer questions with irrelevant pieces of information, it will not fulfill its purpose. So now I want to move on to more of the practical side. What are the human elements that we need to consider when designing explainable AI systems? And the first one we already talked about extensively, who is actually involved, who is asking the question. And different types of people with different machine learning backgrounds or knowledge backgrounds will have different questions. And then the why, we also need to understand the reason behind why someone is asking the question. And lastly, where the explainable AI system is situated is important. For instance, do we have enough cognitive capacity to even engage with the explanation? So in some of our work in insurance, with an insurance partner, we were told that the employees don't actually have time because they're in a fast-paced environment, so they have no time to actually look at an explanation. Similarly, if you're in an automated vehicle, your capacity to engage with an explanation will be very different than when you're at home with like a music recommender. So these last points already led me to some of the challenges and limitations of explanations, and this is very non-exhaustive, this list, and I mostly focus on a few items that are related to trust. So trust is traditionally seen as one of these big goals we want to achieve. We want people to trust AI. We're still in the process of understanding how explanations affect trust in real-world settings, but this is actually mirroring a bit what was said before. We have a lot of evidence to suggest that people over-rely on AI systems, and the explanations are not helping at all because they just blindly rely on them. They see an explanation, they think it must make sense, and they're not really engaging with it. So here the question is how can we create appropriate trust in AI, or what we could also call informed distrust when the output of the AI system is incorrect. So in research, we often act like trust is affected only by explainability of the AI, and once we have it, once we did our experiment, our little tests, people rated it high, and we can check off the box, and we've done our job. But trust is dynamic, and especially in the socio-organizational context, trust can be affected by an enormous amount of factors. Your age, your expertise, your colleague's opinion, the way the AI is designed, whether there is a smiling avatar or not. So it's very difficult and very unclear what it means to trust in AI when we know we've achieved it. And lastly, explanations might not be the answer to everything. AIs are increasingly embedded into the fabric of society, and the question is, can the average non-technical member of the public really ask a discrete, identifiable AI questions to better understand it and decide whether or not to trust it? And related to this, we did some work with some colleagues in Basel to see if, for example, certification labels for AI would be a possible option to communicate specific criteria of trustworthy AI, such as safety and fairness. So here the idea would be we don't ask people to try to understand and trust the AI system, but rather the institutions and structures that govern the AI. But there's quite a lot of work to be done in this area. And so just to summarize, explanations refer to both the product and the process, and meaningful explanations require an understanding of how people cognitively process explanations and also socially transmit them. Explainable AI systems are socially situated and there is no one-fits-all explanation. And lastly, developing effective explainable AI systems requires taking into account challenges such as blind trust, as well as limitations with respect to their use. Thank you very much.
Thank you so much, Michaela, for your insights and presentation. Now, our last but not least speaker is Riva Schwartz. She's a research scientist at the Information Technology Laboratory at National Institute of Standards and Technology, where she serves as a principal investigator on bias in artificial intelligence. Her research focuses on evaluating AI system trustworthiness, studying AI system impacts, and driving understanding of socio-technical systems within computational environments. Welcome, Riva, and thank you so much for being here. You have 10 minutes for your presentation. Riva, you're muted.
Sorry for that. Apologies. Can you all hear me? Can you hear? Yep.
Yes, we can.
Okay, great. I had it on full, but I will just, I had it on full screen. Let me do that. Sorry. Thanks. All right. Thank you. Apologies for the delay. Thanks so much for having me here. Today, I'm going to talk to the stated goal of how explanations are meant to be set in a context, quote, that depends on the task, capabilities, and expectations of the user of the AI system, unquote. I want to talk about the importance of contextuality in AI/ML, evidence regarding the difficulty of operationalizing context, and how in the work that we've done at NIST in the AI risk management framework can help address and improve organizational conditions for, quote, doing contextuality. So first, we start with trying to understand why context is so important and also so difficult within AI/ML. The extensive heterogeneity of data and use cases for AI has become an undeniable challenge for managing its risks. This has been made especially clear with the rise of generative AI. And the very act of machine learning and modeling approaches remove these contextualities and reduce heterogeneity to make the practice of AI tractable. But these practices also make clear that we do not capture context well in computational environments and practices. So what do we mean by context? This is bigger than the pipeline, where we tend to define context as a domain, purpose, task, or use case. At NIST, we are defining contextual factors here as the circumstances, incentives, and organizational and social and societal norms that together shape the normative and empirical expectations about the performance and impacts of AI technology within a given domain and for a specific purpose. So we have tools right now, such as generative AI, that produce extensively homogenized content from highly heterogeneous data, context, and users, but we're currently unable to effectively take up, map, or integrate contextual factors within and across the lifecycle. Right now, we tend to do this, to the extent that we do it at all, through extensive documentation and transparent approaches towards transparency, but these current mechanisms are likely too narrowly defined and practiced. So AI systems don't do context well, and depending on organizational practices, tools, skill sets, methods, et cetera, AI actors aren't doing context well either. So what is the evidence that contextuality is different, or at least not second nature in the practice of AI and machine learning? From a practice perspective, and because this is my area of AI bias, I want to just illustrate this challenge by pivoting for one slide to AI bias. The information on this slide is from our NIST document on bias titled Towards a Standard for Identifying and Managing Bias in AI, SP 1270. The big takeaway from this document is that AI system risks and resulting negative impacts do not only stem from the domain, the purpose, or the task, or from challenges with data sets, models, or algorithms. Or more to the point, this is not just a tech problem. We tend to approach most problems, however, in technology from a computational perspective for many reasons, both of which everyone has just talked about already throughout the day. In the area of AI bias, researchers have traditionally covered it from an almost exclusively computational perspective, even as the community understands these biases are complex and come from outside of the pipeline itself. So in our document, we describe 3 types of bias. I won't go into it because it's not the focus of this conversation, but in addition to the traditionally covered computational bias, we argue that systemic biases and human cognitive biases are in fact not just present in the computational aspects, but add new layers of risk. So as you can see from the slide, there are many, many biases. This is just a sampling, and they are not all able to be wrestled with in current existing machine learning practices. They are contextual and heterogeneous. AI systems are built and used within organizational environments based on individual and group decisions across the enterprise, across the life cycle, and reflect a variety of incentives and purposes. They are also highly contextual, highly heterogeneous. These implicit factors, unknown or unarticulated system limitations, come with a real lack of systemic or structured approaches to consider them, as Dr. Lipton was saying earlier. So enter the AI risk management framework. In January 2023, we delivered this after it was congressionally mandated for NIST to do. We carried out an open and transparent process over 18 months with private industry, civil society, academia, and government entities. We heard from over 240 organizations. And in the end, delivered this voluntary resource for any organization that designs, develops, deploys, or uses AI to manage their risks. We do this through the operationalization of AI system trustworthiness within a culture of responsible AI practice and use. If the goal is better approaches for capturing context, socio-technical approaches are highly likely to get us there. And the framework is a socio-technical framework. The activities laid out in the framework and an accompanying playbook, which is all available on our website at airc.nist.gov for the resource center. These help organizations build up their socio-technical footing by considering risks and impacts in context, in the definition of context that I laid out earlier, by fostering an internal risk culture, by operationalizing governance through accountability structures and practices such as team independence for critical inquiry, and through enhancing skills across the lifecycle that are beyond and outside of the pipeline. So these are the trustworthy characteristics we outline in the AI RMF. And as you can see, explainability and interpretability are on this list. A socio-technical lens on AI system trustworthiness means that we recognize these characteristics interact out here in the real world. They are contextual, and that even if we're hitting it out of the park on performance in silica, in the real world, in context, there are humans who will simply not trust systems. There are always trade-offs between these characteristics and between the concept of trustworthiness and organizational incentives and broader societal values. The question, as we all know, in explainability is often explainable to whom or interpretable to whom. This is a contextual question, but our tools are currently rudimentary for most of these different audiences outside of the data science, desktop and computer science and modeling activities. From a public perspective, if an individual can't understand how and why, and really for most audiences, it's about why, an AI system made a decision, trust becomes very difficult. And when systems cannot be situated into a context or adapt to the human expectations, it makes this challenge even harder. So how do we get better at doing context and understanding systems from this socio-technical lens? We released the framework and the playbook to help organizations get better at these practices. And the AirMF Core is where these activities really take place. And so this is what you see on the slide. The core is composed of 4 functions: map, measure, and govern in a sea. Map, measure, and manage in a sea of governance. I'm going to really just focus, in the interest of time, on the map function, so I should note that all of these, every function will happen iteratively and not necessarily in the same order, but without governance, without strong governance and organizational buy-in, none of this stuff can take hold. But the map function, which tends to really come first if you're starting with a brand new product development, for example, the whole goal of the map function is to consider context. But before that happens, you need to make sure you have the right people in place. And this is, within our lifecycle, we have extensive list, and in the document, in the framework itself, we have an appendix that describes who the AI actors are, and we require significant improvement in the skills within the lifecycle and within organizations that carry out AI to consider context, and so that they can carry out these tasks. So tasks like context mapping, consideration of limitations, impact assessments, which also requires participatory methods to interact and engage with people who may be affected by AI. And so the closer we get to context, the closer the people are to awareness of context, the better we can understand it. Right now, most of those AI actors are rather far from the context itself, and instead are defining it more related to the AI system task or purpose. So I'm going to leave it there, and happy for questions. Thank you.
Thank you so much, Riva, for your interesting presentation. So in the interest of time, let's move on to the Q&A session. The first question is about the trade-off between accuracy and interpretability. Libraries have been filled about this topic, and the question is, do you think that requiring algorithms to be explainable could limit the predictive power of artificial intelligence? I don't know if, Zachary, would you like to go first and maybe tell us your experience perhaps in the healthcare research, and afterwards we can speak with Michaela?
I mean, I think at the outer scope, the question sort of to become meaningful requires that we fix some notion of what it means to be explainable or interpretable. Obviously, like there's this cottage industry where explanations are something that is generated post hoc and sits outside the and now obviously, you know, where I stand on that I have serious doubts about whether the methods that fall into that category are actually doing what anyone is interested in. I think, you know, there's the family of notions of interpretability that concern like the simplicity of the hypothesis class, you know, like what it means to be interpretable is to have a model of some restricted form. Yeah, surely if you adopt that notion, you say that's what I mean by interpretability, then you collapse the entire like interpretability accuracy trade-off onto like the familiar kind of like bias variance of like, oh, but you know, you restrict the expressivity of the model, you have you'll pay a cost in the accuracy, at least in the large data limit. You know, Now, I don't know. I think there's a separate question. I want to like pass the baton to my other co-panelists to answer, but I think there's a separate question of whether that's actually like the central issue is about interpreting is about trading off interpretability versus accuracy versus a concern about whether we're even pointed in the right direction at the right notion of interpretability in nearly any of these cases. And I think I would tend to favor that area that I think that point that I think we generally are standing on very soft ground about whether we're even doing the right thing concerning interpretability, such that I think that's the first order concern is, are we even addressing the concern that the stakeholders have, not sort of what are we giving up in service of it.
So, thank you so much. Michaela?
No, I mean, I agree with that, let's say there's other concerns that we need to first address before we talk about what we're giving up. The other thing I would just add is that, I mean, there's the question of context also, right? If, for example, in the keynote, there was a paper mentioned that by Cynthia Rudin that she argues that we should always use interpretable methods in high stakes decisions, and that it's always possible to, she also has a paper about showing how it's possible to reach high performance. But I think in the end, it's a matter of context and defining what we really need. And I think in in high risk situation and decision making, we really should think a lot about what we really want there and what are the questions we need to answer.
Thank you so much. So, question from the audience.
Yes, thank you all for the interesting presentations and talks. Since we mentioned fairness in the last presentation, and this is not a question to the last presenter actually, I feel like we're treating AI a little bit unfair, right? Because we talked a lot about contextual data, and explainability is contextual related or heavily depends on the context. And I was thinking maybe if we give AI, like taking in the example of the questions that you asked, why you're sitting on a couch, maybe because it's comfortable, or I'm looking at the time. Well, all of these are actually correct answers in a way or another, right? Maybe the difference is that the humans interpret them as they are not the most accurate answers because we know more context than the AI. We're present in the situation, we're looking at the person, and once we ask, we expect a different answer. But the couch is comfortable is absolutely correct answer. I think because humans differ from AI in that we do know more context in that situation, and our brain capability probably evolved over many years so that we know how to reason better in a certain extent. So I was thinking if we give AI more contextual information and more time to evolve and enhance the quality of the outcome, no matter what you measure it with, probably we can reach a point where we can compare AI explainability or reasoning to the human being.
I can take a stab at that. I mean, I'm sorry, I also am having some kind of coughing issue. I think there's a lot to that, certainly. But I think the question is how exactly just feeding systems contextual information without knowing we don't really know how to train AI systems for context. Just giving it more data, more contextual data is likely to exacerbate biases. However, I think there is something to that. I also don't think that means we're getting rid of the need to include humans in making sure that the performance is still safe and effective and not risky, et cetera. So yes, I think that, and I think that's a potential future line of inquiry as well.
I would just add to that I think the difficulty is that we usually have goals in our head, right? We have a goal in mind of what we want to achieve, and this is something that we have to give the AI system. We cannot just simply let loose and feed it with more data. So I think this will always be a question. How do we explain for the right goals and the reasons?
So we have another question from the audience. So I'm going to read this. It's quite long. Training these models requires so large amounts of data, and often it is unclear if they have been lawfully collected. How do you approach trust when the distrust comes not only from the decisions made by the model, but by the nature of the collection of the data that is being fed into?
I think that, this is something that I talked about at the end of my presentation, the question of trust. We approach it quite simply, but actually this is one of the main problems. I mean, there's we can take into account the whole life cycle of an AI system, and then what exactly is the trust, where does the trust start, sort of, and so this is actually, I would say, an unsolved problem. How do we do that? Yeah, it's a good question.
I don't know if Riva or Zachary want to add something. Otherwise, maybe we have another question from the audience.
I could just add briefly that I think generally, like this aspect of transparency around what data was collected for the task, what criteria were used to shape the cohort, what considerations drove those decisions, what commitments were made about what the data actually represented, what efforts were made to investigate the sort of the integrity of the measurements ostensibly reported in the data. These all are, I think really central aspects of trust. Companies, I think, very often report performance characteristics of models, and these are sort of statistics that are only meaningful contingent upon some notion of what is the population against which this model was sort of trained and benchmarked, and without sort of having any of that information, you can't even take, people talk about accuracy versus blah, but you can't even, without this kind of transparency, you can't even know what accuracy means. And so I think
Zachary,
that
we have lost you. Okay, you're back.
okay, sorry about
now
that.
you're back.
Okay, anyway, broadly, I think that ultimately, like, accounting for the data that's used to train the model and to evaluate it, and the processes that went into forming that are absolutely like a central aspect of trust. I think it's difficult to do that well, but
Also, just to wrap up here, panel 2 is concluded, and I want to thank again the speakers for coming and being here with us today and contribute to this very interesting discussion. Thank you.